Hello students, this is our third lecture of audio video engineering. The second unit, that is digital TV and display devices. In the last lecture, we have seen different types of television transmissions, analog television transmission and digital television transmission, and in detail we have seen the classification of both the television transmissions and everything. We have seen analog television transmission, that is subdivided into PAL, NTSC and SECM system, and after that we have seen digital television transmission, that is divided into two types, that is composite encoded DTV transmission and component encoded DTV transmission. After that, component is subdivided as MAC, that is multiplex analog television technology component, and advanced DTV technology. In the advanced, we have seen ATSC, DVB and ISDB. All this the classification of television transmission we have seen in detail. Today we will see what is actually the television transmission. Let us see a DTV transmitter, that is digital television transmitter. The block diagram shows DTV transmitter block diagram. What the blocks actually present in that are camera that we use for the purpose of recording the audio and video, ADC, after that MPEG2 data compression. We have to use here data compression technique, that data scrambler. After that, Reed-Solomon error detection, then trails encoder, then packetizer, multiplexer. After that we are using frame for matter. After that, DAC, SB, filter, ADC, AC, 3 data compression, multiplexer. All this block we will see in detail what is actually the digital TV transmission diagram that we will see now. This is a typical advanced DTV transmitter. We will see here we are having CCD video camera whose output are Y, U and V signal. After that we are having ADC, that is PCM stage, analog to digital converter. After that we are having video compression, that is MPEG2. This technique we are using for the purpose of compression. After that we are having multiplexer. Multiplexer is used for video signal and audio signal to combine both the signal. For the audio signal we are having mic which will receive the audio signals, and ADC is used for the purpose of converting that analog signal to digital signal. And after that we are using same compression for the audio signal as we have used in the video signal. After the multiplexer we are giving it to the DTV modulator, and after that it is telecasted. Now let us see in detail how this typical advanced digital TV transmitter works. The diagram shows a component encoded typical advanced DTV transmitter block diagram. In this particular component encoded advanced DTV transmitter, we will see we are having CCD video camera that is used for the generation of R, G and B signal that we will generate from by using the Y, U and V signal, which then this particular CCD video camera we are using for to generate the RG and B signal, which then we will convert to the analog Y, U and V signals. These analog Y, U and V signals are given to the analog to digital converter we are using here, where Y is sampled with 13.5 MHz, U and V signals are sampled with 6.75 MHz. Sampling or digitization formats applied is 4:2:2 according to the recommended CCIR 601. Then the resultant bit rate output that will be given by 13.5 MHz, that is the sampling rate at Y is sampled, into 106 into 8 plus 2 into 6.75 into 106 into 8, which will give 216 Mbps. That is nothing but the resultant bit rate that we will get here. MPEG2 video compression is applied to the bit stream of 216 Mbps that we have calculated now, and compressed to the 3 to 6 Mbps bit rate. After that, MPEG2 compression reduces the size of data by a factor of about 50:1. By this factor, that size of the data is reduced and it discards a lot of visual information that the human eye would not notice it was missing. Analog sound signal available from the mic, we are getting whatever the analog signal that is being recorded at the mic, that is converted into the digital signal with the help of analog to digital converter. We are using PCM technique here. The bit rate is quite high and hence compression is applied here. Here also bit rate is quite high, so that to reduce the bit rate we are using the audio compression MPEG technique. Audio signal is then compressed by using MPEG-1 audio compression technique here. Thus, the compressed video data and compressed audio data is multiplexed and a final channel data is ready for modulation and for the broadcasting purpose. Thus, the channel data that can be broadcasted by using terrestrial broadcast, that is using either ATSC, DVB or ISDB standards, or we can use for the cable broadcasting for the users of cable subscribers using either ATSC, DVB or ISDB standards, or we can broadcast it by using the satellite broadcast using either ATSC, DVB or ISDB standards. System clock generates the clock for the different timing, multiplexing and control pulses. That's why we are using the system clock here. Multiplexing and sequencing controls are applied because entire digital bit stream is being processed here. Thus, we can say that the component encoded advanced DTV transmission and reception that overcomes all the problems of composite DTV and MAC DTV technology here. This is all about a typical advanced DTV transmitter. We have seen component encoded DTV transmitter. Now we will see typical advanced DTV receiver, that is component encoding technique for the DTV receiver in detail. This is the block diagram of commercial DTV receiver. It is a component encoded typical advanced DTV receiver block. In that DTV receiver tuner, we are using that particular tuner to tune the following signals, that is terrestrial broadcast signal, then cable broadcast signal and satellite broadcast signal. The demodulating signal, the demodulated signal that is given to the demultiplexer unit, where compressed video bit stream and compressed audio bit streams are separated. The compressed video bit stream is given to video decompressor unit, and video compression is achieved by using MPEG to video decompressor. The decompressed digital video data bit stream that is given to the video DAC, that is digital to analog converter for the D2A conversion purpose. The video processor that we are using here is used to give different video effects like picture in picture or slow motion effects in the digital television receiver. This section is also facilitates the different video interfaces like AV interface, YPB interface, or different interfaces. We are using here VGA interface or DVI interfaces over the TV displays or monitors. The compressed audio bit stream that is given to the audio decompressor unit, and audio decompression is achieved using MPEG-1 audio decompressor unit. The decompressed digital audio data bit stream is given to the audio DAC for D2A conversion purpose. Finally, processed audio signal is given to speakers system where the audio information is reproduced. System clock and sequencing control we are using, that is essential because the entire bit stream is being processed digitally. Hence, for the purpose of synchronization, we are using here system clock and sequencing control unit. SMPS power supply that is required where mains voltage is 230 volt AC 50 Hz, that is given a stable DC voltage with different capacity supply voltages that are produced for different stages, which are used in advanced DTV receivers. This is nothing but the typical DTV receiver, that is component encoded typical DTV receivers we have seen now. Now let us see basic actual block diagram of the DTV receiver. It consists of the receiving antenna, tuner, then demodulator also we are having. Now let us see what are the different terms related to it. A DTV receiver. DTV receiver with a set-top box that permits the reception of digital television. Its components are very similar to a desktop PC. It is very similar to the just like a PC that we are having, desktop of the PC. The DTV receiver is a vital link in the chain of television system. The goal of broadcasting system is to concentrate the hardware requirements at the source to simplify the receivers and makes it and inexpensive as possible. The main feature of a DTV receiver that may be classified as: it decodes the incoming digital signal. First, it decodes the incoming digital signal, verifies the access rights and security levels, then displays the cinema quality picture on the television sets, then outputs the digital surrounds sound, and processes and renders internet and interactive TV services. Now let us see DTV tuner that we have used in this particular practical diagram of the DTV receiver. The ATSC tuner, that is DTV tuner module, is available for accessing QAM, OFDM and QPSK based networks. In addition to the receiving inputs from digital networks, most tuners are also capable of tuning analog broadcasters. Tuners can be divided into three broad categories. Broadcast in-band tuners, that is nothing but once the signal arrives from the physical transmission media, the IB, that is broadcast in-band tuner, will isolate a physical from a multiplexer of channels and convert to baseband signal. Means we are having a multiplexed signal. Whatever the multiplex signal we are having, from that multiplex signal, this particular signal is subdivided, or that is converted into the baseband signal. The term baseband is used to describe a single channel or digital signal that extracted from the broadband signal, which is basically a stream of multiple channels. Means whatever the signal that is to be transmitted, mainly from the transmitter, that particular signal that is extracted from the stream of channels or number of signals in the channel. Second one is out of band tuner. In this type of tuner, that facilitates the transfer of data between the head end system and the set top box. They are widely used in cable set top boxes for providing subscribers with medley of interactive services. Implementations of the OOB, that is out of band tuner, tend to operate within 100 to 350 MHz frequency band. The third type of tuner, that is return path tuner. In this tuner, it allows the subscriber to activate the return of path and send the data back to the interactive services provider. Implementation of this tuner tends to operate within the 5 to 60 MHz frequency band, that was 100 to 350 MHz of frequency band into the OOB. Here it is 5 to 60 MHz of frequency band. Now let us see the next point, that is modulator and demodulators of that particular receiver circuit. The function of the demodulator, that is to convert the analog signal to the digital bit stream. Then it checks for the error and it forwards the bit stream to the demultiplexer. The modulator reverses the actions of the demodulator and its function is to deliver a signal to the return path tuner. That is the purpose of modulator and demodulator here. The demultiplexer and decryptor circuit, the technology that is used in DTV television is MPEG-2, that is for the purpose of compression we are using MPEG-2 and MPEG-1. The demultiplexer that selects the particular packet, decrypts that particular and forwards it to the specific decoder. After that, the decoder, that is a DTV receiver, will normally contains 3 separate decoders for converting the digital bit stream into a format that can be heard and viewed by the subscriber. That is the need for using the decoders. A video decoder, it transforms video packets into the sequence of pictures which are displayed by the TV monitor. Audio decoder we are using, it decompresses the audio bit stream. Different audio modes are usually supported by the DTV receiver, and mono and dual channel, stereo and joint stereo are extracted by using this decoder circuit. And graphic processor we are having, that is the main purpose of the graphic processor is to render a range of internet file formats and proprietary interactive TV file formats. After that, we are having a central processing unit here. What is the use of that central processing unit? And that there is a memory management unit in that particular receiver, that also we will see. The central processing unit, the CPU, like in a desktop PC, is the brain of the DTV receiver. DTV also consists of that particular CPU, that is the brain of that DTV receiver. The functions that is provided by the CPU are initializing the various hardware components that are present in the receiver circuit of television. It processes a range of internet and interactive TV applications, monitors and manages the hardware interrupts. It fetches the data and instruction from the memory that was stored in the memory, and it runs various programs for that particular memory. That is the use of central processing unit, the main, that is heart of television system, DTV system, sorry. And the purpose of using that is we have to initialize number of components. It fetches the data from the instructions from memory. It runs various programs. Now we will see what is the purpose of memory. As a computer, a DTV receiver needs a memory to store and manipulate instructions. Most elements within the receiver requires memory to perform various tasks: the graphics engine and video decoder. Okay, this is all about the particular DTV receiver, which is having, which is smart way we are using as compared to the analog televisions. We are having memory, we are having CPU, different video and audio compression techniques. We are using multiplexer and demultiplexer. We are using for the decryption of the data that is multiplied, modulated at the transmitter. Modulators, demodulators we are using for the purpose of modulating the data, and again extracting the whatever the original signal was modulated at the transmitter. This is nothing but the exact explanation of television receiver, that television receiver of the digital TV, digital television receiver that we see at our home. Now let's move towards the next point, that is MAC signal. Let us see what is actually the MAC signal. In the last lecture we have seen a MAC signal, that is multiplex analog component signal. In that we will see multiplex analog components, that is MAC, that was satellite television transmission standard, originally proposed for use on a Europe terrestrial HDTV system, although it was never used terrestrially. The simultaneous PAL transmission of all television picture elements and the multiplex transmission of TV picture elements with the D2MAC signals. MAC transmit luminance and chrominance data separately in time rather than separately in frequencies, as other analog television formats do, such as composite video signal. This is nothing but the MAC standard. Now let us see. The MAC technique is capable of superior video quality. It is similar to the improvement of component video over composite in a DTV player. Its major drawback was that this quality was only ever realized when the video signal being transmitted remain in component from source to transmitter. If at any stage of the video we have that has to be handled in composite form, the necessary encoding and decoding processes would severely degrade the picture quality by the encoding and decoding processes. The terrestrial TV broadcasters were never able to take full advantage of MAC signal quality due to multiple interactions between the composite and component signal paths. Direct to home, that is DTH, and TVRO broadcasters were able to take the advantage of MAC's improved image quality because their studios and routing facilities were far less complex. The success of NICM audio for terrestrial television that can be traced to the success of MAC technology. The MAC audio subsystem that is nearly identical in design and functions to the NICAM system. During the 1980s, Europeans attempted to define a common standard for satellite broadcast with a goal of improving picture and sound quality by eliminating the drawbacks of the composite system cross color, cross luminance and reduced bandwidth, and by using the digital sound, that particular results in the Mac system with a compatible extension towards the HDTV, that is called as HD Mac standard. D2 Mac, that is most well known of this hybrid system. It replaces the frequency division multiplexing of the luminance, chrominance and sound of the composite standards by a time division multiplexing. It is designed to be compatible with normal 4:3 and widescreen 16:9 format, and can be considered in some aspects as intermediate step on the route to all the digital TV transmissions here. Okay, this is all about the Mac standards we have seen, and what is actually the Mac signal. Now let us see the advanced Mac signal transmission, how actually that particular Mac standard technologies transmission occurs. The key feature of the B Mac signal formats are separation in time of the luminance and chrominance information that we have seen before, the transmission of both luminance and chrominance as the baseband signal, also the transmission of audio in a digital form in the line blanking period, transmission of vertical and line synchronization information as digital codes, as opposed to PAL system, which uses a frequency division multiplexing method to combine the elements of the television signal. Mac system uses a time division multiplexing system. Here we are using time division multiplexing system, and in the PAL system, frequency division multiplexing system was used to combine the elements of the television signal, that is video signal and audio signal. The diagram in the next slide we will see that shows the typical Mac packet television line, Mac packet system that are also used in several European countries. They are very similar to B Mac. This is nothing but the TV transmitter or the Mac packet television line transmitter. This diagram shows the block diagram of typical DTV transmitter that is using Mac technology. Means typical Mac DTV transmitter block diagram is this on the screen. In this, the time compression we are using with the factor 1.5 that is applied to the luminance signal. After that, the time compression that is with the factor 3 that is applied to the chrominance signal. We are having two signals, luminance and chrominance. With the factor 1.5 that we are applying to the luminance signal, and with the factor 3 we are applying to the chrominance signal. Sound and data signal and synchronization signals are converted into the digital signal using ADC, and then digital compression that is applied to these signals. Thus time multiplexer that is used to multiplex the time compressed U, V and Y signals with the digitally compressed sound and data with synchronization signal. Thus, these multiplex analog component, that is MAC signals, are FM modulated for the satellite uplink for typical DBS, that is digital broadcast satellite broadcasting purpose. Also, these all the multiplex analog component signal or MAC multiplex signals are AM VSB modulated for the cable broadcasters. And here in this particular MAC signal broadcasting, we are not using terrestrial broadcaster, that is not applicable in this particular MAC signal. Thus, MAC DTV transmitter is used to transmit the MAC signal for DBS broadcast using FM modulation and for the cable broadcast using AM and VSB modulation here. Now let us see a typical MAC DTV receiver. This is the block diagram of typical MAC DTV receiver. In the block diagram, we will see FM demodulator for DSB receiving signal we are using from satellite, and AM VSB demodulator we are using for the purpose of cable receiver signals. We are having two receiver signals. One is for satellite receivers and second for cable received signal. And terrestrial broadcasting reception is not applicable in the case of MAC signals. Here, two types of signal that can be received or processed, like FM modulator for DSB signal for satellite and AM VSB for the modulated signal for cable. FM demodulator is used for DBS received signal from satellite, and AM VSB demodulator is used for the cable received signal here. After that, there's the MAC signal that is given by the MAC decoder that performs some of the functions, that is demultiplexing of component Y, U and V, sound data and synchronization signals. After that, time decompression of Y, U and V signals for Y by factor 1.5 and U and V by the factor of 3. Digital decompression of sound, data and synchronization signals. Here, the decompressed audio bit stream from MAC decoder that is converted into the analog and audio by D2A converter, analog audio signal that is then pre-amplified and power amplified by amplifier stages, and then finally it is given to the speaker. The particular MAC technology we are using, it supports mono, stereo as well as 5.1 digital theater multi-track audio system, and hence accordingly the audio processing stages can be modified. That's why it supports different audio signals. That's why it can be modified by using different stages. Decompressed video signal from MAC decoder that is processed in video processing stage, and the typical decompressed synchronization signal that is bit stream from MAC decoder that is converted back into the analog by D2A converter, and then further it is processed in the video processing stage. We can see in the diagram the video processor that is used for the different video effects like PIP and slow motion effects in DTV picture receiver. Thus, we can see here the MAC DTV receiver, it produces a high quality audio and video outputs for the purpose of receivers to receive the signals. Now, let us see the different technical challenges that we are facing for the MAC signal transmission. Here we can say, although the MAC technique is capable of superior video quality that is similar to the improvement of component video over the composite in a DVD player, its major drawback was that this quality was only ever realized when the video signal is being transmitted, that is remain in component form from the source to transmitter. If at any stage the video that has to be handled in composite form, the necessary encoding and decoding processes would severely degrade the picture quality. That is one of the challenge in the MAC signal. The terrestrial TV broadcasters that were never able to take full advantage of MAC image quality due to the multiple interactions between their composite and component signal paths. The direct-to-home TVRO broadcasters were able to take the advantage of MAC's improved image quality because their studios and routing facilities were far less complex. Thus, the success of NICAM audio for terrestrial television that can be traced to the success of MAC technology. Thus, the MAC audio that is subsystem is nearly identical to the design and functions of the NICAM system. Now we can say that since the vast majority of TV stations and similar installations were only wired for composite video signals, the fitting of MAC transmitter at the end of the chain had the effect of degrading the transmitted image quality rather than improving that quality. For this and other technical reasons, particular MAC system were never really get caught on with broadcasters. MAC transmission technology that was made obsolete by the radically new digital systems like DVB-T and ATSC in the late 1990s. Here, MAC transmission systems are still used. The technology is obsessed. It is expected that MAC will cease to be used for TV transmission by the 2012. Though these technical challenges, MAC signal is having so many advantages. The particular MAC signal that can offer a higher performance than the composite system because of separation of luma and chroma signal. We are separating these two signal, which eliminates the cross modulation, and use of full bandwidth of luma and chroma signal is preferred here. In MAC, the picture synchronization is ensured by means of the time multiplex data signal. With MAC signal, higher performance is readily possible because of separate components. The programmability feature of the Mac video and synchronization system has also the advantage of flexibility for future changes and improvement in the television technology. The Mac processors produces all 625 lines on each scan instead of interlaced scan, so that the higher definition picture can be displayed here. The component coding has advantage to change the required video formats in the Mac. This is nothing but the number of advantages of the Mac technology. Thank you.